the first, you could make all of them, and I'm just going to represent makes by checks. Second, you could miss all of them. Third, we're going to say make, miss, and then you could have any combination of two makes and a miss. So make, miss, make. You could also miss, make. And then we could have any combination of one make and the rest misses. So make, miss, miss. Miss, make, miss. And miss, make. So there's 8 possible options there for you. All right. So Darius Washington was a 72% free throw shooter. Find the probability that Memphis will win, lose, or go into overtime. When you have found the probabilities, put them into the table. So if he's a 72% free throw shooter, points making all 3 would win the game. So 3 makes would be 0.72 times 0.72 times 0.72, or 0.373. Losing would happen if you had 0 makes and 3 misses. So I'm going to change that color. So 0 makes, 3 misses. So if he's a 72% free throw shooter, then he will have a 28% chance of missing. So 0.28 times 0.28 times 0.28, and that gets you 0.022. They would also lose the game if they had 1 make and 2 misses, which would be 0.72 for the make, 0.28 times 0.28. That would be 0.056. But if you were to make 1 and miss the rest, that would be any of these 3 options up here. So what I need to do is take 0.056 and I need to multiply that by 3, because there's 3 ways of that happening. In order to go into overtime, we would have 2 makes and 1 miss, which would be 0.72 times 0.72 times 0.28, which gives us 0.145. And if we look up here, I'm going to get this out of the way. There are 3 ways of that happening, so we need to multiply that by 3. All right, now let's take a look at what's going on down here. So the probability that Memphis will win is if they make all 3 of them, because if you add 3 on, then that would become 76 to 75. So that would be 0.373. Now the probability that Memphis would lose would be 0.022, which was that number right here, plus 0.056 times the 3 ways it could happen, which that number would be 0.169. So 0.022 plus 0.169 gives us 0.191 as the probability of them losing. The probability of overtime is 0.145 times 3, which would be 0.435. So that's calculated from up above. All right. Now, if we had 2 shots remaining, then the score would be 75 to 74. Probability that Memphis would win would be a make and a make, which would be 0.72 times 0.72, which would equal 0.5184. The probability that they would lose would be 2 misses. So miss and miss would be a 0.28 times 0.28, and that would be 0.0789. And the probability of overtime in this case would be like a make, a miss, or a miss and a make. So that would be 0.28 times 0.72. And then this up. There are 2 ways of doing that. So you have to multiply that by 2. So times 2, and that is 0.4032. Okay, and now at this point, if the score is 75 to 74 and you only have 1 shot remaining, the probability that Memphis can win, well, if they only have 1 shot left, they can't possibly win. They can only lose or tie, so that would be 0. Probability that Memphis would lose is if they miss that shot, which is to miss is 0.28. And the probability that they win or go into overtime is if they make that shot, which is 0.72. So now this says Washington is a 40% free throw shooter. Do you think Louisville was smart to foul? Why or why not? Well, it could be smart to foul. So we're going to say maybe on this one. Why we're going to say maybe is because the chance of losing in regulation goes down, but they might have to go into overtime and lose there anyway. So they Washington very well could have made it, but Louisville could have been smart to foul because then that gave them a chance if they were going to kind of press them to see if they would win or not. So maybe because the chance of losing in regulation goes down, but they may have to go into overtime. Okay, so now let's talk about some of the main ideas of this section. So we're speaking specifically here about binomial random variables. I know I didn't really talk about that in the activity, but any case where you have a set number of trials, in this case it was a set number of shots that had to happen, that's a binomial setting. So if we are talking about binomials, there is a trick to remember the parts of binomial, and that would be bins. B-I-N-S. B stands for binary, which is like two options. In this case, there's a make or a miss. I stands for independent trials, which every shot is technically independent of one another, even though they always use this example with binomial situations with the basketball, but obviously they might not be independent of each other because shooting a basketball where it's a lot more high pressure, say if you're down to the last point of your final game, then that might not be independent of one another, but we're going to just assume independence here. And N is a set number of trials. In this case, we are shooting 3 times, and S, the same probability for each one. So then another thing that we need to talk about today is the binomial formula, which is the probability of X equaling a certain value, which would be like getting a certain number of shots. So there's something called N choose K, and then you would multiply it by the probability to the number you're interested in, which is K, times 1 minus that probability to the N minus K, where N is your total number. Here, let's take a different color. P or K is the number of successes you want. P is the probability of a success. And then this P and 1 minus P must add up to 1. So I'm going to take it up first really quickly to the top, or back to what we were dealing with, to show you how this would work in this scenario. So what would be the probability of 2 makes and 1 misses? So our probability of success is making in this case. So 2 makes, so that would be, I'm going to change the pen color again. So that would be, in this case, we have 3 total shots, 3 choose 2, probability of making it's 0.72 to the second power times 0.28 to the 3 minus 2. So then if we were to do that, okay, so 3 choose 2 in this case is actually just 3 because there are 3 options, and we're going to go back over how to find that. I'm going to show you in a calculator tutorial how to do that using your calculator, but for now, this N choose K is just N factorial over K factorial times N minus K factorial. So that would be 3 factorial over 2 factorial times 1 factorial, which 3 factorial is 3 times 2 times 1. which is 3 times 2. 2 factorial is 2 times 1, so that would be 2, and 1 factorial is 1. So 3 times 2 is